Hello dear student, you are welcome to my video lectures. Myself Professor Ashok Kumar, and I am working in Department of Mechanical Engineering at Dr. Subhash Technical Campus. The chapter number 3 that we are going to discuss and it is velocity and acceleration analysis part 2. As we know that this chapter contains a little bit large portion and there are numbers of subtopics are present, so I have divided the entire chapter in 3 parts: part 1, part 2 and part 3. So during my previous video lecture on same chapter, velocity and acceleration analysis part 1, in which specially I have discussed about linear velocity and linear acceleration. Then I have started various methods which are to be widely used for the calculation of velocity and acceleration of different points on various links for any kind of mechanism. So in that particular lecture I have discussed specially relative velocity and relative acceleration method, and secondly I have also discussed on an instantaneous center method through which we can determine velocity and acceleration of different links. Let's start the remaining types of method that are being used for the calculation of velocity and acceleration of different links. Before it is very important to discuss here about linear and angular acceleration. Basically linear acceleration and angular acceleration is the kind of we can say that related with the linear and angular motion. Acceleration basically plays very important role for the development and design of machine itself. So it is very necessary herein to know first what is linear acceleration and what is the angular acceleration. If we are talking about linear acceleration, then we can say that the rate of change of linear velocity with respect to time is known as linear acceleration. So that means suppose any body having the linear velocity and you are rating it that linear velocity of that body with respect to time, of course it will become linear acceleration. And it is not necessary that the direction of the velocity and acceleration vector remain always same, but in case of retardation both of the vectors, that means linear vectors for linear velocity and angular acceleration or linear acceleration, both have the opposite direction, we can say that. Now according to definition, rate of change of linear velocity with respect to the time that will be known as generally linear acceleration. So over here that is the rating of velocity with respect to time, but we know that the velocity is the rate of change of displacement with respect to time. So generally over here ds represents the change in displacement or linear displacement. So ultimately equation for the linear acceleration will becomes d by dt, and over here in case of v, put that values of v from here to in that location. So ultimately you are getting d square s upon dt square, that is the equation for the n acceleration. Also you can find acceleration equation in such a manner that dv upon dt, and if you are dividing and multiplying with displacement, change in displacement in like that, so ultimately you are getting that dv upon ds will remain dv upon ds, but ds upon dt, that will be the linear velocity. So ultimately in that equation we can conclude that the acceleration is generally product of change in velocity with respect to distance, that means this term, and of course its relation with velocity. So a product of velocity and change in velocity with respect to displacement is of course known as a acceleration. So that was the definition about the linear velocity and acceleration. Similarly, you can also have the definition and understanding about the angular acceleration. Angular acceleration generally defined as a rate of change of angular velocity with respect to time. Just you have to put the angular velocity in place of linear velocity. By definition, ultimately you are getting angular acceleration. So angular acceleration will be known as alpha, and it is the rate of change of angular velocity with respect to time. Here d omega, that is the change in angular velocity, not linear velocity. Kindly note down that in case of angular acceleration, you have to take care of the change of angular velocity with respect to time. But we know that angular velocity is defined as change in angular displacement with respect to time. So again, put that value of omega in this relation, and simplifying it, you will have d by dt into d theta upon dt. So ultimately angular acceleration alpha will become d square theta upon dt square. So this is what about the linear acceleration and angular acceleration, and its definition and mathematical relation. Now we are going to discuss point number 2, and that is motion of particle moving in a circular path. That means suppose any mechanism or the link which is circulating or rotating around fixed point, then what will be the motion that the particle has during while it's circulating along the circular path. That is very important for the analysis as well, the design point of view of any mechanism and link. So this theory in which we especially discuss about particle which is moving in circular path, then what's the motion characteristic of that particular particles. Now look at the diagram. You have given one link OP, and it is moving on a circular path about fixed center O in clockwise direction, and it radius of rotation, or say the radius of that particular link, that will be we can say that is OP. Now let the particle moves to point Q in some interval of time, let's say dt time. So within dt time it will move from P to Q. So its angular displacement becomes d theta when it moves from P to Q. One more thing you have to consider is that at point P the particle has linear velocity v, but whenever it is traveling through some distance like angular distance d theta and reach at the point Q, now its linear velocity will be changed, and linear velocity at point Q will become v plus dv. Generally this velocity is always has been the direction and tangential to that of the particles which is moving around this circular motion. So this we can say that the tangential velocity is of course changing from v to v plus dv. Over here that whatever the increase in velocity, that is the dv, due to change in position of the particle P which is moving to the distance, or say the point at Q. So that's why due to that small angular displacement of particle P which is moving to Q with d theta displacement, angular displacement, over here the velocity, linear velocity of course will be changed and increase a little bit like v plus dv. Now same phenomena can be represented by we can say that the vector diagram. So first of all, draw a vector OP and OQ, that means OP and OQ, which both of the vector are representing the direction of that point Q and point P's velocity over here. So in that manner you can have the vector diagram like OP and OQ. Now ultimately we require to have the change, whatever the velocity that is being changed during that particular displacement d theta, then closing side of this vector, that means PQ vector, will represent whatever the change of velocity is being produced during the displacement d theta. Now kindly think about that particular resultant side, that means resultant velocity, that is being the change of velocity during location change p to q, it can be resolved basically in two direction. One is horizontal direction and one is in vertical direction. And of course both of the vector of that resultant vector can be resolved. One is in horizontal and one is vertical, strictly on the basis of the one vector should be drawn parallel to link OP and one is the perpendicular to OP. That means vector PA over here, which is perpendicular to this link OP, and QA, that means AQ vector, is of course parallel with that particular OP link. So now by looking carefully this vector diagram, we can conclude that vector PQ that is equal to summation of vector PA plus vector AQ. Now we know that the vector PA is of course OQ cos d theta minus OP. So this is the relation for vector PA, and by putting the values of OQ as well OP, OQ stand for the V plus dV and OP stand for the V. That means suppose you are looking for the vector OP, that means the magnitude of velocity in this vector is V, whereas in case of OQ you are finding that the magnitude of velocity will be V plus dV. So ultimately you have to replace OQ and OP by V plus dV and minus V. So ultimately equation for the PA will become V plus dV into cos d theta minus V, and by solving that relation you are getting PA is equal to dV, that means change in velocity. One more thing, whenever you are separating, you are multiplying cos d theta with each terms inside the bracket, you will find that there is a minus V and positive V. That will be cancel out, but there will be dV cos d theta will remain there. So ultimately cos d theta is very small, so you can ignore the terms cos d theta along with dV. So ultimately you will have the PA vector is equal to D in dV. Again consider the vector triangle OQA. In this vector diagram you can have relation like AQ vector is equal to OQ into d theta. Again OQ will be replaced by V plus dV, and by simplifying that relation you will have V plus dV into d theta. So again V into d theta plus dV into d theta, but herein dV into d theta contains very small values, it can be neglected. So ultimately you will have vector AQ is nearby equal to V into d theta. After that relation of vector AQ, now it's very easy to calculate the tangential acceleration and centripetal acceleration. So ultimately we can say that the tangential acceleration will become like vector PA and upon we can say that dt, that means change of the angular velocity PA with respect to time dt. So ultimately you can put the values of PA from here. So centrifugal acceleration will become like f suffix t is equal to dv upon dt. And on the same way you can have also the centripetal acceleration, that means the acceleration which is acting inside or towards the center of the link or center of the circle. It will be generally it is the basically ratio of vector AQ and you are rating it with time dt. So ultimately this relation will become centripetal relation. And again as what we have derived already, AQ is replaced by V d theta. So ultimately over here AQ is replaced with V into d theta upon dt. That will be the centripetal acceleration. So this is what about the motion characteristics of any particle which is moving along the circular path, and by adopting the velocity triangle. First of all, you require to do a velocity triangle, then you just resolve resultant side into two direction. One is perpendicular and one is parallel to that link OP that you have given. And by simplifying further, you will have the two components of acceleration. One is acting in centripetal direction, and of course other is acting in centrifugal acceleration. So this is the theory about motion of a particle which is moving in circular path. So now third method that is being widely used also for the calculation of velocity and acceleration, that is Coriolis component of acceleration. Up to now, what we have discussed, the various types of method for the calculation of velocity and acceleration of a point with respect to another point on the same rigid link. Generally, it has two components of acceleration. One is in horizontal direction and one is in vertical direction, that we have seen in previous slide. But this is good when the distance between 2 points is fixed and the relative acceleration of 2 points on the moving rigid link is considered. This is somewhat we can say that limitation to that in order to apply the previous method, in order to have the calculation of acceleration, one point should be fixed relative to other. But if the distance between 2 points varies, for example second point which was stationary and now it slides, the total acceleration will contain one additional component along with the centrifugal and centripetal component of acceleration. Third acceleration, or we can say the third type of element regarding the acceleration will be introduced in that, and that will be the Coriolis component of acceleration. So suppose you are finding any mechanism in which the other point, that means second point, is moving constantly or sliding constantly. At that time you have to just go through for the Coriolis component of acceleration. And this type of mechanism in which especially this phenomenon happens, where the second point that is sliding along the path or along the link continuously whenever the link is moving or rotating. So such type of example of mechanism you can see in quick return motion mechanism of workshop shaper machine. So particular that mechanism, while analyzing that kind of the mechanism, you just need to go through Coriolis component of acceleration method, because due to sliding nature of the other point, the third component of acceleration must be introduced, and that will be the Coriolis component of acceleration. In order to discuss in detail, consider that you have given one quick return crank and slotted lever mechanism, in which specially consider the link OA that you have given, which oscillate about the fixed center O with the constant angular velocity omega from point OA to OA1 in very short time dt. Now let d theta be the angle between OA and OA1. That means the angle turned by that particular link OA to OA1. That angle, this position is displaced, or for the new position to reach the d theta displacement is necessary for the link OA. And also the slider B moves outward whenever link OA is rotating and sliding with velocity Vs. So C is the coincident point with slider OA. So slider moves with rotation of new position from C to C1. You can see from the figure that the slider is moving from C to C1. In order to understand the motion of slider in detail, first of all just go through point C, where motion from C to C dash due to rotation of the link caused by the tangential component of acceleration Ft. You can see from the figure, that means whenever link is rotating and slider is moving over here, there will be tangential acceleration will be produced. And whenever the motion from C dash to C double dash, that means of course this slider is rotating and sliding along with rotation, so it will also move from C to C dash. So at that time it produces centripetal acceleration FC, that means this. So we can conclude that whenever the link that is moving from OA to OA1, that means in this position, slider goes to have the two types of the acceleration component that are being produced. One is centripetal acceleration, tangential acceleration whenever it moves from C to C1, and other is centripetal acceleration when it moves from, we can say that, C to C double dash. Again, motion from C double dash to C1 dash, it result into one more, or we can say that the third types of component of acceleration, and that what it represented as a Coriolis component of acceleration. So this is what about what and how the component of various component of acceleration that are being generated while any link is moving along with the one point is sliding and having the rotational motion too. Now it is very important to calculate or determine magnitude of a third component, that is a Coriolis component of acceleration, and for that kindly go through the two diagram that you have given. Consider a link OA which is rotating about a fixed point O with uniform angular velocity omega in anticlockwise direction. Due to that, the slider block B is sliding along the path, or we can say that the link OA with a sliding velocity V suffix S, and C is the point on link OA which is instantaneously coincident with the B. You can see from the figure. Now from the figure we can write that OB is equal to, we can say that OC, because C and B is coincident with each other. So relation becomes like that: OB is equal to OC, and of course that will become the radius of that particular link about which the link is going to be rotated. And of course by taking the triangle like OB, and of course this triangle if you are taking and converting the entire relation in terms of y, then you are getting that the y is equal to r sin theta. Now that relation of course should be make differentiation of that relation that you are getting from selecting triangle y is equal to r sin theta, in that manner that dy upon dt, that will be the r cos theta into d theta plus sin theta into dr upon dt. But we know that d theta upon dt, that is equal to omega, that means the rate of change of angular displacement with respect to time, that will be the we can say that the angular velocity, and of course change of we can say that the radius with respect to time, or change of displacement with respect to time, that will be the sliding velocity. So over here both of the term can be replaced, and by putting that value over the above equation, you are getting a final relation that the dy upon dt that is equal to r cos theta omega plus sin theta into v raised to 4s, that means the sliding velocity. Now again you have to differentiate this equation so that you are getting at the end the relation for the acceleration. So by differentiating this equation, you will have d square y upon dt square, that is equal to omega in bracket r minus sin theta d theta upon dt plus cos theta into dr upon dt plus vs into cos theta into d theta upon dt plus sin theta into dvs upon dt. Again from this equation we can say that dvs upon dt, that will be the radial acceleration, and a change in angular velocity with respect to time, that is equal to 0, because w that means angular velocity is constant. So by putting that both of the value in above equation, that means this equation, you can have the final equation or relation that is d theta upon dt is equal to omega, and dr upon dt, that is vs. So ultimately your equation will become d square y upon dt square, and that is equal to omega in bracket minus r sine theta plus into omega plus cos theta into vs, that means sliding velocity, plus bracket vs cos theta plus into omega plus sine theta into f. So by further simplification, you can have the relation for the d square y upon dt square, that is equal to minus omega square into r into sine theta plus omega cos theta vs plus vs cos theta into omega plus sine theta into f. So basically this is the relation for the Coriolis component of acceleration. This relation represent actually the Coriolis component of acceleration. So by adopting this procedure, at the end any mechanism which is sliding along with rotation, you can find the third component, that is Coriolis component of acceleration. After that, number 4, that is the Klein's contraction. Again, this is the method through which we can calculate the Klein's. We can calculate and determine the velocity and acceleration of the various links which is assembling in various mechanism. Basically, Klein's contraction is the graphical method, and it is suggested by Professor Klein for determining the velocity and acceleration of various links for reciprocating agent mechanism. Look at the diagram. You have given one reciprocating mechanism. So by using Klein's theory, Klein's procedure, you can have the velocity and acceleration of various links. Generally, what we have seen in case of relative velocity and relative acceleration method during my previous video lecture, we have determined the velocity and acceleration of various links of reciprocating agent mechanism by just drawing separate velocity and acceleration diagram. But the special feature of Klein's contraction, or we can say that the Klein's velocity diagram, is that there is no need to draw a separate velocity and acceleration diagram as that of relative velocity and acceleration procedure. You can draw within the mechanism itself velocity and acceleration diagram, and in that way you can have the determination of velocity of and acceleration of various components. So due to that, this method is very simple and time consuming to draw various velocity and acceleration diagram is very low if you are comparing it with relative velocity and relative acceleration method. Look at the screen. There is a figure of we can say that the reciprocating engine mechanism, in which it is actually IC engine mechanism, in which OC is work as a crank and PC is the connecting rod, whereas P stand for the piston. Now the crank makes an angle theta with the line of stroke PO, that means this is the line of stroke PO, and crank is making an angle theta in that way. For example, this is the angle theta, that is angle of inclination of crank with respect to line of stroke, or we can say that stroke line. Now crank rotates with uniform angular velocity like omega radian per second in clockwise direction, and its angular acceleration will be alpha, and that will be equal to 0 because the crank rotating with angular velocity. So ultimately angular acceleration will be 0. There will be no any kind of change of angular velocity with respect to time. So ultimately angular acceleration alpha, that will become 0 in this case. Now in order to draw Klein's velocity diagram, just you have to follow a few steps. Number 1, that is first draw configuration diagram of slider crank, or we can say that the IC engine mechanism. And secondly, draw a line through point O and perpendicular to line of stroke OP. You have to draw a line that is from the point O, and which should be perpendicular to, we can say that the line of stroke. That means this line you have to draw. Third, extend the connecting rod PC. That means you have to extend this line connecting rod PC in such a way that it intersect the line previously we have drawn at point F. So over here ultimately you are intersecting line extension of line PC and line OM in this case. Once you have done, then kindly consider there will be a triangle OCM. So over here that will be the triangle OCM. You have to focus upon it, and this triangle is generally known as we can say that the velocity triangle of Klein construction. So you can understand that it's very easy that to draw a velocity diagram by using the Klein construction method. Now look at the right hand side figure that you have given. Actually it is velocity triangle which is drawn by using the concept relative velocity and relative acceleration method. So actually it is velocity triangle which is drawn based on or by using the relative velocity and acceleration method. Now just you have to compare both of the triangles. One is through the draw one triangle from using the relative velocity method, and one is by using the Klein construction procedure. Now if you are comparing both of, you can easily understand the effectiveness as well as the efficiency of that particular Klein construction. Now first of all focus upon the triangle OCP, in which specially OC represent the velocity of crank, that means VCO, and which is parallel to OC. Similarly vector OP in case of triangle OCP will represent velocity of piston, that means V suffix P, which is parallel to OM line. And of course PC, vector PC represent velocity of connecting rod, that means V suffix CP, and again it is parallel to link CM. Now both of the triangle you can take the ratio like small OC upon capital OC of Klein construction is equal to small OP upon capital OM, that is equal to small PC upon capital CM, because over here we can say that OC is coincident with capital OC, OP is again coincident with OM, and PC again coincide with MC. So basically this is the relation that we have taken by considering both of the triangle. One triangle that is taken by relative velocity method, and one is from the Klein construction. So if you are taking a ratio of that particular parameters, of course it should be always constant and it will be equal to angular velocity. And of course if you are replacing these all terms, that means links with the velocity component, it will become OC is equal to VCO, that means OC that is equal to VCO, so you have to put over there. Again OP, that means this it will be represented by vector or velocity of piston VP, and finally PC, that means this link is represented by the velocity component of the CP, that means here. So by putting so, you will have the relation like we can say that VCO upon OC is equal to VP upon OM is equal to VC upon MC, that is equal to W. Now from that relation you can clearly evaluate the velocity component of a different link. For example VCO, you can have VCO is equal to omega into OC. VP, that means velocity of piston, that will be O into OM. We can say that VCP, that means velocity of the piston, that will be equal to omega into MC. So this is how you can have the calculation or determination of velocity component by using simply Klein construction. Now again, if you want to wish the velocity calculation of any point that is given on the say connecting rod PC, it can be also calculated by using Klein construction method. Just you have to take the ratio in such a manner that Cx upon Cp, that means this is Cx, and divided by Cp should be always equal to Cx upon Cm, that means Cx upon Cm. So if such a ratio, proportional ratio have the equal relation or equal magnitude, Then convert this relation in terms of Cx. So you will have Cx is equal to Cm into Cx upon Cp. Again, we can say that Vx can be calculated, that means velocity of point x that is located on connecting rod PC can be calculated by using the relation omega into Ox. So this is how we can calculate velocity of any point which is located on connecting rod at any distance from either end. So dear student, in this video lecture we have discussed about linear and angular acceleration. Then after we have also discussed about motion of particle which is moving in circular path, in which we have specially calculate two types of acceleration component, tangential and centripetal acceleration. And of course at the end we have also discussed about the planes construction. If you are finding any query or any topics, let me inform. We have the solution. Thank you very much.